Hello everybody, we're going to talk about some transformations of linear functions. So I have two equations. We're going to graph and answer up some follow-up questions that talk about what do these two lines have in common and what is different about these two lines. So I already put them in slope-intercept form, y equals mx plus b. If they weren't in slope-intercept form, such as standard form, they don't have y by itself, then I'll probably rewrite it algebraically to get y by itself so I could graph it. Okay, so I have y equals negative 3 over 5x plus 6, which means my y-intercept is 6, so I'm going to put a point there. And my slope is negative 3 over 5, which means since it's negative, we want to be going down. So I'm going to go down 3, 1, 2, 3, and to the right 5, 1, 2, 3, 4, 5. We're going to continue that trend. Down 3, 1, 2, 3, and over 5. 1, 2, 3, 4, 5. Once we have a few points there, we can line up with a straight edge and graph it. So there's my first line. To the next one, y equals negative 3 over 5x minus 3. So my y-intercept is at negative 3, which is right here. And my slope is negative 3 over 5, which again is downward. So I need to go down 3 and to the right 5. Down 3, 1, 2, 3, right 5. 1, 2, 3, 4, 5. Do that again, down 1, 2, 3, to the right 5. 1, 2, 3, 4, 5. I'm going to take that straight edge, line them up, and graph them. Okay, so looking at those two graphs, we need to figure out what is similar or what do they have in common. Now, when we went through that process, you should have noticed, hey, wasn't the slope the exact same? So the slopes are the same. Now, one other thing I want you to notice with that is graphically, just look how these almost look like the same line. They're going down at the same rate. But notice, and this is where we're going to bring in the differences, this line started much higher, where this line started much lower. So what's different was their y-intercepts. So the slopes were the same and y-intercepts. When the slopes are the same, they almost look at the exact same line. They're just located at different spots on the graphs. This is above the center, the origin. This is below the origin. Okay, slopes were the same, different y-intercepts. So on the back here, I have two more problems, and we're going to look at a few other scenarios. So we're going to graph the following, answer the follow-up questions that talk about what do they have in common, what's different. So y equals 2x plus 2. My y-intercept would be at 2. So I'm going to go on my y-axis to positive 2, put a point. My slope is 2, or 2 over 1. So I'm going to go, since it's positive, we're going to go upward. So I'm going to go up 2 to the right 1. Up 2, right 1. Up 2, right 1. Up 2, right 1. Up 2, right 1. Once I have a few points, I'm going to take a straight edge and draw my line. To the next line, y equals negative 2x plus 2. My y-intercept is at positive 2, which is right here on the y-axis, positive 2. My slope is negative 2x, or negative 2 over 1. Not the x, it's included in the slope. Negative 2 over 1 is my slope. So since it's negative, we need to be going down. So down 2 to the right 1. Down 2, right 1. Down 2, right 1. Down 2, right 1. Once I have quite a few points there, I'm going to take my straight edge and graph. Okay, so we need to talk about what was in common. So in those two processes, we should have noticed things that were in common. Notice where we started. We both started at the same spot on the y-axis, so their y-intercept is the same. So where I cross the y-axis is the exact same. What's different if you notice the slope over here, that they're very similar, the slopes, except this is positive 2 and negative 2. Remember slope, dude. Positive slopes, we're going to be going upward from left to right. Negative slopes, we're going to be coming down as we go left to right. So these slopes were different. So with transformations, it's always good just to graph them. A lot of us are very visual people. It's a lot easier to see what's going on instead of just staring at equations. Because sometimes these can be in standard form, it makes it very tough to see. So again, I would get them into slope-intercept form and graph them. Sometimes even when you get them to slope-intercept form, you can usually look at these equations and tell the differences. Standard form's a little bit tougher to see. And that was transformations on lines.